Hi, everyone, and welcome to today's discovery session. These sessions are meant to support students, businesses, and other organizations with an understanding of how to use data and artificial intelligence. But before we get into it, I'd like to begin by acknowledging that DeepSense works out of Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the Treaties of Peace and Friendship. We'd like to recognize the Indigenous peoples of all the lands that we're on today. We want to ask that everyone takes a moment to consider the territory in which they're situated and their own personal responsibility in the processes of reconciliation. My name is Alyssa, and I'm the communications specialist with DeepSense. For those of you who don't know what DeepSense is, let me give you a little bit of an introduction. DeepSense is a project based out of Dalhousie University in Halifax, Nova Scotia, but we work with universities and colleges across Atlantic Canada. We work with companies in the ocean sector who are interested in harnessing the potential of data and creating a smarter ocean economy. We connect these companies with the next generation of AI, machine learning, and data experts, aka our students. We work with companies to create a project that best suits their needs, and then we find a researcher and a student to help execute the project as either a master's research project, a co-op, or an internship. We've had past projects in data analytics, data collection, data visualizations, data cleaning and processing, and of course, AI and machine learning. Projects could be anything from creating a deep learning model to track fish, or creating a prediction model for safe navigation in the Halifax Harbor, or even a computer model that can identify whale shapes from aerial images. If you've ever wanted to grow your skills and work on real projects and gain industry experience, then make sure you submit your info to our student pool. Projects, internships, and co-ops pop up throughout the year, so it's useful to throw your name in there because it's the first place that we'll check to find someone to fill a position. I'll share the link for the pool in the chat in just a moment, and make sure your resume is rocking because we want you to stand out, since only those who are selected for an interview will be contacted. And for today's session, we'll be learning about MLOps to better understand and implement machine learning operations strategies effectively within the AWS ecosystem. We'll look at the complexities of MLOps workflows, specifically how to use Amazon SageMaker Studio for efficient model deployment and management. We'll look at how integrating machine learning operations practices into the development lifecycle can help ensure machine learning model scalability, reliability, and maintainability. This discussion is critical for anyone involved in developing, deploying, or managing AI solutions, such as data scientists, engineers, and IT professionals. We'll learn how to optimize their workflows, improve collaboration, and reduce operational overhead using MLOps. And today's session is led by Prakrut, our cloud engineer at DeepSense, headquartered at Dalhousie University. At DeepSense, Prakrut is responsible for working on AWS, Azure, and Google Cloud, managing cloud infrastructure and setting up high-end instances for machine learning training on various cloud services, and troubleshooting GPU and machine learning environment issues on cloud. Prakrut has a bachelor's degree in computer engineering and has also worked as a freelance developer. He recently finished his master's in applied computer science at Dalhousie University, and he's worked on several machine learning projects in the healthcare field and was a member of Google Developers Group, where he gained interest in cloud. He grew up in the capital city of Gujarat state in India, where he found a love for the environment. He enjoys traveling, especially exploring new places and hiking, as well as photographing the frames creatively from his perspective. And if you have any questions throughout the presentation, we'll be taking them at the end. Feel free to drop them in the chat at any point during the presentation, or you can use the question and answer box. And that is enough from me. Let's hear from Prakrut.
Yeah, thank you, Alyssa. Thank you, everyone, for joining. So let's start with share screen. Okay, yeah, can you see it?
Yeah, we can see your screen well. Thanks.
Okay, perfect. Yeah, so welcome everyone to the discovery session. So today we'll be talking about MLOps. So most of people would know about it. We just most had a little bit idea of it. Most doesn't have any idea of it. So we'll dive deep into it and check it out what's this about. So we'll be covering today benefits of MLOps, implementing MLOps on SageMaker Studio. We'll have a nice demo and go through the real-time processing of how does MLOps works on AWS and what are the best practices for MLOps workflow. So to start with, I would like to ask everyone that how many of uh, from the audience knows that what is MLOps actually, and we'll see how many people really know, have a little bit of idea, and what they think about it. Yes or no should work.
Don't see anything in the chat yet.
Yeah, I think everyone is new to it.
Yeah, sounds like it.
Yeah. So let's start with the introduction. The full form of MLOps is basically machine learning operations. So it's quite related to DevOps. Most of people have heard DevOps, which is also related to it. And it's basically uh, the efficient method for developing and improving the quality of machine learning. And we can adopt many MLOps approaches to allow data scientists and machine learning engineers to collaborate and accelerate their development in production. And with that, we can also implement continuous integration and deployment, which will be very beneficial if they want to do that repetitive process of machine learning. As you can see here, that it starts from data, then we do modeling, and then we create planning, and all those cycles can be automated. So while doing that, we can just uh, do the first thing and configure everything first and make the pipeline of it. And then we can just use it again and again whenever we want to. So this is a basic introduction. Uh, for talking about production and machine learning operations. So nowadays everyone is building AI models, but production is harder. I haven't seen many companies doing that. Many people are very good at development, but when it comes to productionize that application or making production of that specific models, it is a little bit harder. So right now, MLOps is quite gaining interest, and many companies are starting to using it because this is the kind of future of machine learning and how we can automate the whole pipeline. So there was a report from 2019 which says that only 30% of the machine learning models reach to production. So everybody's doing development and everybody's trying to create specific models from their requirements, but not all the models and all the machine learning models reach to production. And as we know, AI adoption has increased in past few years. So I had this last statement, like the research report, which says 56% of companies are getting AI, and now I think there are more than 70 or 80% companies are interested in it, and all the companies wants to do that. There was recent Apple launch was also dedicated to it, that they have launched many AI services and inside Apple, and all the larger companies are adopting AI. So for successful adoption of MLOps, it returns better on the investments that we do, and because most it helps to reduce the time for prototyping and development, and most importantly the deployment. So MLOps is right now combining technology with organizational change, and it's offering the straightforward path to production and greater longevity of models. So yeah, this is a basic graph of how over the time it's getting trending. So next we will talk about the importance of machine learning operations in ML landscape. So as we discussed that production is difficult, machine learning lifecycle has many complex components, such as first we start with the whole pipeline to get data and cleaning the data, manipulating the data, and training the model, and then testing the data, and then if we do improvement stuff. So in all of these stages, it is very hard to, if you want to automate everything, then we must use machine learning operations. And it also requires more collaborations and hands-off across a team, from data scientists to data engineering and ML engineering. As you can see, the MLOps is the uh, includes everything. It also works with the machine learning team, also works with the DevOps and data engineering to gather the data so that we can create the whole end-to-end machine learning cycle and make it automated. So for basically it's a machine learning cycle that we are going to automate it. And to better understand the machine learning, first we can start with understanding what is CI/CD. So CI says continuous integration and continuous deployment. So which stands for which aims to streamline the exploit the software development cycle. So CI refers to practice of automatically frequently integrating code changes into shared source code repository. So, and there's also version control, which is the software engineering practice of controlling the computer files and versions of files, which primary are source of codes and text files, but generally they are any type of the data. And version control is also a component of software configuration management. So version control system is a software tool that automates the version control. And same goes for model serving infrastructure, that in machine learning, we are uh, working with models, and in production environments, we need that facilitates the real-time inference and predictions. And at last, we will be doing some monitoring and observation, because after we produce a model and we want to have what outcomes that it gave, then we have to uh, do constant monitoring and observation. We can discuss this in the next slides. So this is the basic MLOps flow. So as I told before, that we can automate the whole process. So if we just we have already trained a model and we just want to train it again with a different data set or different aspects, we can just have everything ready in MLOps, and we just have to trigger it from starting. Or if it's a manual process, we can just start from manual run, the manual pipeline run. Then it goes to the data repository to get the data set and all the data that we need. And we can also start with the code quality check, data validation, and then we can train and validate the model, review it and approve it, and registering the model. So this whole is called the training pipeline, and there's another one is the release pipeline, which is mostly for deployment and production environments. So after we get our model ready in the model registry, we get it into package, and then we deploy it into test environment. We tested out the whole thing, and we deploy it on the prod, and we can also add a stage to smoke test those things. And after we can add a stage to operate, monitor the model, and if there are any model drift or data drift. So basically data drift is whenever we have something new in data. For example, there were in COVID times, the credit card usage from online has been increased very drastically, rather than we had in our normal lives. So if we are predicting any credit card detection or fraud detection, then that can be detected fraud. But it's because of the COVID that it's happening, then we have to monitor that, and this stage can help to achieve come over that issue of the data drift and model drift. So basically, that's the importance of how why we should monitor the models more often. So that was the basic MLOps flow, and then next we have MLOps platform. So right now we were working with the stage AWS SageMaker. That is the most frequently used and overly used cloud for MLOps. But if we want to do it in our local, and if you want to use any third party application, there's an application called MLflow that really helps to tracking of the experiments that we are doing, and it creates projects, models, and we can register those models to use it again. So basically, there are so many other platforms that we can use for MLOps. As you can see in whole the life cycle, there are many other platforms that we can use like Kubeflow, Data Robot, and MLflow is the majorly used. If you want to use any other, then AWS, but AWS can also work with MLflow. That can be a little bit complex, and it depends on how uh, the requirements of your project. How does that? So now the components of machine learning operations. Uh, I guess we already discussed this, but it's, let's go again. First, we can also start with data analysis, data preparation, and feature engineering. So it's basically the machine learning operations that we do on any of the machine learning or AI project. And have just automated everything with the MLOps, and we can create a whole pipeline, and it will be automated model retraining. So the benefits of machine learning operations. First is productivity, we discussed that it's very fast. If you don't want to waste time, and you let's say data engineers and data scientists have to collaborate on one project and they want everything on one place, they can change from their side, and data engineers can change from their side, and it can be reflected in the whole pipeline of machine learning operations. So it moves faster, and very fast, uses less time to gather information of any missing data or invalid data. And another thing is repeatability. So automating all those steps that in the machine learning cycle, that helps ensure that the repeatable process are done. If we don't do it manually, sometimes if missed out in any of those components, that can cause issues in our deployment or a training or evaluation part of it. Another one is reliability. It is reliable to stay on machine learning operations and have everything done by them. And it's very good at if you want to do an audit on if we find any issue with our model, it will be very easy because we can find all the versions that we go through while we were developing the whole model, and it will be we can demonstrate exactly how the model was built and where it was deployed. And the last one is the data and model quality. So MLOps is let enforce the policies that can guard our model bias and track changes to data statistically, and process properties to gain the model quality over the time. So now it is the same as if anyone has attended the Auto ML session. The infrastructure and cost implications are very minimal. It doesn't really affect much if we are doing normal machine learning jobs or we are using MLOps. It's just that we have to configure it while we are modeling the whole process. So it uses pay as we go model. So whichever instance type and duration and how much data we have stored, and the model deployment depends on how we have managed the endpoints and those instance types and those aspects. And yeah, it's managed infrastructure, so it has variety of instances that can work really fast, high performance instances, or there are many scaling options and endpoint auto scaling that is also available with those options. And yeah, we already covered uh, data pipeline optimization is also there, and fine-tuning the hyperparameter jobs and implementing the lifecycle policies in Amazon S3 to improve the cost efficiency. So there are three major clouds that provides the whole MLOps thing. We can start with AWS SageMaker. So it has its own UI, and we can use it like IDE that we have for other programs in our local host, like local computer. It starts with the collaboration at scale. We can create multiple accounts on a same domain. We call it a domain when we work on the SageMaker Studio. And it's very easy to experiment management, and we can automate model generation. There are many higher quality models that are available and increase productivity. For MLOps SageMaker overview, as we talked about the pipelines, SageMaker has its own SageMaker pipelines that does all the things that we discussed before, automating the model and building the workflows and retaining the workflows if that's needed with different data set. And for SageMaker model, for model registry, SageMaker has its own. So we can do model configuration and metadata management in that model. And then we can use that in production after the workflow gets approval. We can set it to approve from our higher management, like a senior developer or senior machine learning engineer. They can approve the model and then it can go into production. And this is the whole diagram of how SageMaker MLOps working. So they have experiments. So we can experiment as a project. So we can create experiments and then we train the model, training inside it, and use model registry to register the model. And using CI/CD pipelines, we can configure those commits, and we can also use AWS code pipeline to also work with the commits and version control, and then we can deploy the model, and with that we can also do monitoring. And with Azure, it's a little bit easier, and the different parts of Azure, it's very clear to work with, but yeah, it's still very kind of complex to understand. It has its own Azure DevOps pipelines that we can use in our MLOps pipelines, and with that we can create machine learning pipeline endpoint with uh, the service that Azure is providing for machine learning compute. So yeah, there are many good things about Azure, that it can manage resources more easily than AWS, but at the end, AWS provides more options to go with. So AWS is right now top priority, but Azure is very near to it and it can do really great. Google Vertex AI is also provides the same. It has a Vertex AI data set we can directly use, and we can store it in the bucket and create a pipeline, same thing as we do. And yeah, but it's a little bit on the complexity level, it's on the higher side. So it's still not much used in MLOps, but yeah, we can go forward advantages of SageMaker. We already discussed this: easy to use, scalable, pre-built algorithms. Yeah, so there are many pre-built algorithms that we can directly use in SageMaker. That is really great feature of it, and it is the same models as same algorithms as we have, like SGBoost and all of those that are very popular, but it's pre-built in SageMaker, so we don't have to uh, just load the model again and then work on it. We can just directly load it from the SageMaker package and it's ready to work. And yeah, model tuning is also fine, and it's also integrated with other AWS services. So if we're storing data on S3, we can directly get that in our AWS SageMaker, and it can work really well in collaboration with both. We don't have to configure much if we are using all of those services. And there are flexible deployments, deployment on cloud, on-premise, and edge devices. We can deploy it anywhere. Yeah, it depends on the requirement, how we want to deploy. If it's very uh, high performance consuming endpoint, then we obviously have to deploy it in cloud. And it's also cost effective. So yeah, this will be the main components of Studio. We'll see that in the demo. And yeah, there was a new service called SageMaker Canvas, which is more of same as we had in Studio, but we have differentiated with the auto ML thing in Canvas. So in Canvas, you can anybody can use it. You don't have to. You don't need any machine learning knowledge. You can just load the model data set, select the algorithm that you want to use, select the target column, and it can do by its own. And we can also build it, previous model, and then also we can create the endpoint to use it. It also has this MLOps function that we can use to see the overall uh, work that has been done by AutoML and those stuff. So, yeah, let's uh, do towards the demo. So yeah, so this is the SageMaker Studio, and in that we have many options, many features to go with. But as I said, the AutoML thing is now transferred to Canvas. So as you can see, it says open Canvas here, and we have to just it redirects us to the Canvas, and we can work from there. But for other stuff, we can use the Jupyter Lab. Have created one, and that opens in different window with the Jupyter Lab setup that is quite similar of whatever we use on localhost or doing other things. So here we'll just look at how to create pipeline. So right now it's all programmatically done. So we have to write code to create pipeline and understanding why it's work, how it's working, and automating the flow. So here we can just import a few of the packages from SageMaker to create pipelines, processing steps, and we'll be good to go. So in this notebook, it's basically the configurations that are done, and from here we are creating a pipeline with uh, the pipeline parameters that can be anything like processing, instance type, training type. We can define it beforehand, and we can also set it to auto as per the development works for us. And these are the pipeline stages that are currently in this notebook, like in this project that we configured, as we discussed, as data processing, training, evaluation, and condition, and register them. So yeah, we can create one session of pipeline session, and then we can start with steps that processing the data. We can put it into the one step of pipeline, which is called the data processing step. And from there, it's basically all the code things that we have to work. We can provide source. Here it's input URL from S3. So they're getting data from S3 and all the different outputs that we are getting. We can do version control of it. And from that, we can differentiate how the different versions that are available. So that creates a different S3 endpoints, and we can use the different dot model files if you want to use it in the production. So it's very handy if you want to track down the model files and work on the same. Now this is the training step. They have used XGBoost for image processing, and same we have to set the hyperparameters and all the parameters that are required. But here, as you can see, they have used the SageMaker package for doing everything else. So most of people have to learn a little bit about how those SageMaker packages are working. And then we can process a whole training step, and we can just write name and step arguments. And yeah, from there we can proceed to the evaluation step, do the same, follow the structure for SageMaker MLOps that they have provided. Can use this template also. And same goes for the register step. It will register the model into the repository. Then whenever we process the model, it will build the model and save it into the repository. So we can then uh, use it after in the production. And there are other steps also if there is any fail or condition step. And at last, after we define all the steps, we can configure the pipeline with all the steps we have created, step process, train, evaluation, and condition. And after you run all these steps, we can see a visualization of whichever step that we have run. So from to see here, I've already done this before, so I'll just show that. We can just go to in SageMaker Studio, we can go to pipelines, and there are many pipelines that I have run. So we can select this one, and it will show us the whole pipeline that how it should work. If it fails, it will go. It's like a binary classification of the just the diagram. So whenever the first step is done, it will turn green. If it's in a second, it will be gray. So it will be easier for us to understand where the process is stuck, or are there any configurations that are it's stuck upon. There's also we can see for this stage there is this is the model file that it has created. So we can use it directly, and there are other details about the project. Every step is also recorded. So if you want to do audit or monitor anything, that can be done. And it also shows the runtime of the model training. This was the uh, training and pipeline part of it. And after we do complete the modeling, we can, this is the model registry. So we can just, we have used this project. And from here, we can approve the pending state of the model that has been created. So after it gets approval, we can just see, we can directly approve it from here. But yeah, we have to check it out before we approve it. Then it will be directly sent into the production. Like we can create the endpoint of it. So if you want to approve it, we just create it, right? Any little comments? It will be approved. So after a little bit, waiting for a little bit, it will create one endpoint. And right now there is one, but it will create one endpoint, and we can also configure how it will work. So the configuration that we have given in this notebook for using the instances for uh, the production, the endpoint that will be ran directly from here after the model gets approved. So yeah, this was the basic tutorial. I don't want to go deeper in this, otherwise everyone will get bored. But yeah, the basic thing is yeah, also will show the canvas. So in canvas, it's very easy. Anybody can use it. We can create a custom model from for you to use that uh, for any of three model problems we can solve. Yeah, we can just take any of the sample data set, but you can also create data set that are already exist in our system. We can import it from our computer, or we can also get it from S3 bucket, or these are the other options that we can use if there's any DynamoDB or Athena, whenever we are storing the data. And after we build that model, we can uh, also play around with it. We can just create one basic model for start from the beginning. Yeah, then it will be the same. We can have these stages: analyze, predict, and deploy. And it starts with the build. So we have to select data set, import the data set, and then we can do all those steps. We can select the parameters and target values for training, and that's how it will be working. So yeah, this was the little demo. It was, and I guess that's all from me.
Awesome. Thank you so much, Prakrut. So now if anyone has any questions, now's the time to ask. I don't see any yet in the chat or in our Q&A box. So I've got one that I'm happy to ask. How is MLOps different from DevOps? And also, how does it differ from auto machine learning?
Yeah, so DevOps is basically used for the software development lifecycle. So they have a different steps of commits and CI/CD. It's mostly the similar thing as the machine learning operations, but in DevOps they don't do modeling, and for deployment also they have a few steps before that they can do testing and all those stuff. So it's a little bit different than that, but it's almost the similar. It's just that machine learning life cycle, it follows the machine learning life cycle, and that follows the software level.
Awesome, thank you. We've got one from Lou. He says, thanks for the presentation. So for industries, if I have my model, how can DeepSense help us on the deployment of our models? Do we need a cloud engineer, developer, or machine learning engineer?
Uh, so yeah, we can directly deploy a model on and create one endpoint for companies to use. So after the model has been configured, uh, we just have to configure that on the DeepSense AWS or DeepSense any of the cloud, and we can create one endpoint to provide that to companies. And upon the requirements of those aspects, we can use any of the instances that instance type upon the requirements, and I guess cost hourly as per we use. And yeah, we can create that for companies.
Awesome, thank you. And we've got one from Agastya as well. What tips or advice would you give to someone beginning their journey on cloud and AWS?
If they want to begin a journey with cloud, first they can start with some tutorials, understand what cloud is doing actually, and there is one uh, course that is just for understanding the cloud and AWS stuff. But for AWS, if you are really interested and if you have some knowledge, you can also pursue a certification that is AWS Cloud Practitioner. So it after we prepare for that, we get all the knowledge that we want to do, the basic knowledge that we want to have to get started with cloud. So yeah, we get started.
And we've got one more in the chat from Vinodin. He says, amazing session. Thank you very much. And his questions are, what are integration tests in release pipeline? And is this option available on AWS Canvas?
Yeah, so the option, I guess it's not available in Canvas. It's pretty new, and the documentation is very limited for getting started with Canvas. So it's still under process. But for integration tests and release pipeline, basically integration testing is you can test the whole component as we discussed. There are data modeling, and then we have to build the model and all those different components. We can test it together, so that is basically the integration testing that we can do before we release the actual model into production, and how those components works with each other. It is being tested in that step. Yeah, Canvas doesn't provide that, so we have to wait until they provide one.
Awesome. Thank you. I think that's our last question. We've got one more from Agastya.
Yeah,
How does Amazon SageMaker Studio facilitate efficient collaboration between data scientists and engineers?
yeah. So from data scientist and engineer aspect, the cloud admin or system configuration, whoever doing a system configuration, they can create a different account and they can provide them different roles as per their requirements, and we can bound them with permissions that you can share, you can access these resources for data aspects, and these are only for the machine learning operations aspect. And there are already few roles that are readily available on AWS that we can directly attach to them. And as I said, the studio is a collaborative space, so we can have multiple users working on it, and they can all see the whole pipeline, and they can work on their part, and don't have to worry about the other tasks too.
Very cool. Thank you. We've got one more. Is AWS's Canvas MLOps an implementation of MLflow, or is MLflow something open source available regardless of platform?
Yeah, so MLflow is available open source and regardless of any platform. You can also configure it on your local host to uh, register your models, have a proper pipeline, and uh, you can have multiple build stages in MLflow. But in Canvas, as I said, it's very new and hasn't been developed much. It just helps you if you have a pre-configured database that uh, you want to clean it and then create a simple model out of it. So it doesn't have those right now, but I guess in the future it will be in demand because not everybody wants to spend more timing on modeling and doing the same stuff. Yeah.
Okay, awesome. Thank you. And I think with that, we will wrap up. Thank you again for taking time out of your busy day to join us. It's been really great to learn more about how to leverage MLOps to optimize workflows and improve collaboration. I'm dropping some links in the chat right now. And those links are to our student pool and our mentorship program, STEM Connector. That is a flash mentorship program that if you're interested in connecting with folks working in the ocean sector or any of the STEM fields, Sign up today. It's a free Flash mentorship program. So you can connect with lots of different mentors, and it's more one-off meetings that can be done virtually or in person. And if you enjoyed today's discovery session, there are plenty more up on our YouTube channel. So I also dropped the link for that in the chat, as well as all of our DeepSense social medias. And keep an eye out for more discovery sessions from us. We do our best to host one every month. So there'll be another one coming in July. And Prakrut, do you have anything you want to share before we wrap up?
No, I would like to thank everyone for joining the session, and I hope everyone has better knowledge of MLOps now and do some good machine learning and improve AI.
Awesome. Thanks again, everyone. And we'll see you at our next discovery session.
See you.
Bye.
Bye.